Lesson number 90 is about word problems with two statements of equality. And these word problems with two statements of equality are similar to value problems that we looked at in lesson number 89. Our first problem says, together, Charles and Nell picked 92 quarts of berries. If Charles picked 6 more quarts than Nell, how many quarts did each of them pick? So let's use subscripted variables here. We're going to get the number that Charles picked, so the number that Charles picked, plus the number that Nell picked equals 92. Then it says, if Charles picked 6 more quarts than Nell, so we're going to have to say the number that Nell picked plus 6 will equal the number that Charles picked. And then we can go ahead and solve. We're going to go ahead and solve with substitution because this problem tells us the number that Charles picked. It's the number of Nell plus 6. So when we use our substitution here, we're going to get, well, the number of Charles is really the number of Nell plus 6. So the number of Nell plus 6 plus, that's what we've substituted in for the number of Charles, plus the number of Nell equals 92. So the number of Nell plus the number of Nell, well, that equals 2, n sub n, plus 6 gives us 92. Then let's subtract 6 from both sides, so we get 2 times the number that Nell picked is equal to 86. Then we divide both sides by 2, and we get the number that Nell picked is equal to 43. Well, if the number that Nell picked is 43, then we can figure out the number that Charles picked really easily, because 43 plus 6 equals the number that Charles picked. So the number that Charles picked, that must equal 49. Now we can check our answer with our first equation as well, because the number that Charles picked plus the number of Nell should be equal to 92. And 49 plus 43 definitely equals 92. So both equations are correct when we substitute our values in, so we know both of our answers are right. Let's look at another problem. Here we have one. The sum of two numbers is 72. The difference of the numbers is 26. What are the numbers? So let's say the first number, n sub f, plus the second number, n sub s, will equal 72. Because we know the sum of them equals 72. Then the difference of the numbers is 26. So the first number, n sub f, minus the second number equals 26. And now we can solve. Well, if we look at this problem, it sets up really well for elimination because n sub s minus n sub s equals 0. So when we go ahead and figure that out, we're adding both equations together. So we're going to get 2 times n sub f equals 72 plus 26. That must be 98. Then we'll divide both numbers by 2. So n sub f, our first number, is going to equal 49. Then let's figure out our second number. Well, our second number, when added to our first number, equals 72. So if we do that, we've got 49 plus our second number, n sub s, equals 72. So to find n sub s, we're going to say 72 minus 49. And that'll give us our final answer. Well, when we do 72 minus 49, we must get an answer of 23. So n sub s is going to equal 23. We've got our second answer, we've got our first answer, and in this one, we need to check to make sure that they're correct when we subtract them. The first number, 49, minus the second number, 23. 49 minus 23, that equals 26, which is exactly right. So we checked both of our equations. These problems give us answers that work both times. So we figured out the correct numbers for this problem. Let's move on to our last example. The ratio of two numbers is 5 to 4, and the sum of the numbers is 63. What are the numbers? So in this one, let's say again, we know that the sum of the numbers is 63. So n sub f for the first number plus n sub s for the second number will equal 63. Then this problem is different. Because it says the ratio of the two numbers is 5 to 4. So if the ratio of the two numbers is 5 to 4, that would mean, well, our first number, n sub f, over our second number, n sub s, the ratio is going to equal 5 to 4. And if we know that the ratio is 5 to 4, we can go ahead and we can set up an equation by using our cross products here. So what we're going to do is we're going to multiply n sub f times 4. And that's all going to be equal to n sub s times 5. And when we write out our equation like that, this is n sub s times 5. When we write out our equation like this, well, we have an equation now. So we could write it up here. And let's write the numbers out in front of the variables. So we're going to get 4 times n sub f is equal to 5 times n sub s. I'm having some trouble distinguishing the 5 from the s, but I know it's that. And as you write these, make sure that you know that it's that as well. This is the second number, and this is the first number. So if we have this, well, we can't solve right away. We need to figure out what the first number is going to be equal to. So we'd subtract the second number from both sides. It's going to look like this. N sub f is going to equal 63 minus n sub s. And when we do that, we can then substitute our n sub f value of 63 minus n sub s in for n sub f. So we're going to get 4 times 63 minus n sub s equals 5 times n sub s. Let's go ahead and multiply. If we double 63, we're going to get 126. And if we double 126, we'll get 252. So we're going to get 252 minus 4 times n sub s equals 5 times n sub s. Then we're going to add 4 to both sides. So we get 252 equals 9 times n sub s. Then we'll divide both sides by 9. 252 divided by 9? Well, 9 goes into 25 twice. That's 18, with 72 left over. 9 goes into 72 8 times, so we get 28. Perfect. So 28 equals our second number, n sub s. So our first number, well, we know our first number is the second number plus the first to give us 63. So in order to figure that out, we're going to say 63 minus 28. And that will tell us our first number. Well, if we work through this math, we'll borrow from the 6 to get 5, and 13 minus 8 is 5. 5 minus 2 is 3. So we've got 35. Our first number, n sub f, equals 35. We've got both answers. 28 plus 35 equals 63. And let's check to see if this second part is true. Does 4 times our first number, 4 times 35, well, double 35 is 70, and double 70 is 140. So is 140 equal to 5 times our second number? Well, 5 times our second number, 5 times 28. 28 times 5, 8 times 5 is 40, carry our 4. 5 times 2 is 10, plus 4 more is 14. Perfect. 140 is equal to 140. That means we've got the answer right. We checked both of our numbers in both of our equations, and both equations were true. Our lesson practice will be on page 376. Make sure you've got your notes complete, and I'll see you during our next class.